This section 1.7 is on the chain rule, using the chain rule to find the derivative of a composite function, such as the one that I have in the brackets right here, f of g of x. You have an outside function, which is your f, and then the g of x is the inside function. And so, for example, if we wanted to find the derivative of y equals 7x minus 4 to the fifth power. This is not one that you could multiply out easily to use the power rule to find the derivative, so the chain rule is another method of finding the derivative. So what I'm going to do is go over here to the side, and we're going to find the inside function, the 7x minus 4, that's the inside function. The exponent, or the power of 5, is your outside function. So I'm going to let the variable u equal the inside function, 7x minus 4. Now, when we're finding the derivative of the whole function, we're going to have to find the derivative of 7x minus 4. So let's say that du is equal to the derivative of u, or 7x minus 4, which is 7. So I want to write the original function in terms of my variable u and then du. So I'm going to go over here and I'm going to say y equals u to the fifth. Because remember, u is equal to 7x minus 4. Now, if you were to find the derivative of u to the fifth, all you have to do is use the power rule. So that means that y prime would be 5u to the fourth, and you have to multiply it times the derivative of the inside function, which is du. So if you look over to the side, we know what u is, we know what du is. So we're just going to substitute those values in to find our derivative. So I'm going to write this as 5 times, and in place of u, I'll write 7x minus 4, and that's to the fourth power, and then times the du, which is 7. So the derivative y prime is 5 times 7x minus 4 to the fourth times 7. And we could actually multiply the 5 times 7 to get 35 times 7x minus 4 to the fourth. So we took the derivative of the outside function, which is the power, and then we multiplied it times the derivative of the inside function. So that's how the chain rule works. So let's look at a couple more. So let's say that y is equal to the square root of 6x plus 5. Now this one is not in exponential form, and so I want to take it out of radical form and write this as 6x plus 5 to the 1/2 power. Remember, we've done that before. I just have to get exponential form. Okay, so I want to come over to the side. Now, our inside function is 6x plus 5, and the outside function is the exponent, or 1/2. So I'm going to let u equal the inside function, which is 6x plus 5, and then the du, the derivative of u, is just 6. So I'm going to write my original function in terms of u. So y equals u to the 1/2 power. We're going to use the power rule to find the derivative of u to the 1/2. So that would be 1/2 u to the negative 1/2 power, and then you always have to multiply it times the derivative of u, or du. So we want to substitute in for u and du. And this would be 1/2 times 6x plus 5 to the negative 1/2 power times du, which is 6. So you see, I've taken what I had over the side for u and du and substitute in here. Then I need to simplify. I'm multiplying 1/2 times 6. So you see the 2 goes into 2 once, into 6 3 times. So this is equal to 3 times 6x plus 5 to the negative 1/2 power. And remember, you don't want to leave a negative exponent, and you want to write your answer in the form of the original function. And the original function was in radical form. So first, I need to take 6x plus 5 to the negative 1/2 to the denominator, but the 3 stays in the numerator. So it'll be 3 over 6x plus 5 to the 1/2 power, and then to change it back to radical form, I have to restate the numerator, and I write 6x plus 5 to the 1/2 power square root of 6x plus 5. So that would be my derivative, 3 over the square root of 6x plus 5. Okay, let me do one more. Okay, this one is going to be y equals 2 over 9x minus 4, and that's going to be to the 6th power. So this is my original function, y equals 2 over 9x minus 4 to the 6th. And again, we need to get this in exponential form. So I need to bring over the 2 and then bring 9x minus 4 to the 6th out of the denominator. So when I bring it out of the denominator, change the exponent to a negative 6. So that's in the correct form that I can use to find the derivative with the chain rule. Okay? So what is the inside function? What is u equal to? U equals to what's in the parentheses, which is 9x minus 4. And then we have to find the derivative of that. The derivative of 9x minus 4 is 9. So that's what du is. So I'm going to write my original function in terms of u. So y equals 2, because I've got that 2 there, u to the negative 6. So if you've got a number outside the parentheses, when you write in terms of u, you've got to put that number there. It's a factor times it. All right, so the derivative of this, using the power rule. Now bring down our exponent, negative 6, we have to multiply it times that 2. So it'd be negative 12 u, and when you subtract 1 from negative 6, it means to the negative 7th power. Don't forget, multiply it times the derivative of u, or du. All right, so this is the derivative in terms of u and du. Now I want to substitute back in my values for u and du, so the negative 12 times 9x minus 4 to the negative 7th times 9. So I can multiply negative 12 times 9. Those are two constants. So that's going to be a negative 108. And then I have 9x minus 4 to the negative 7th, but we don't want to lose the negative exponent, so that's got to go to the denominator. But the negative 108 stays in the numerator. It's going to be over 9x minus 4 to the positive 7. There's your derivative, y prime. Let me do one where we find the equation of a tangent line, similar to ones that we've done before. A little bit room here. They said we're going to find an equation of the tangent line to graph of y equals the square root of 4x minus 3 at the point 1, 1. Now remember, to find the equation of the tangent line, you've got to have a point on the line, which you're given, 1, 1, and the slope. Remember, the slope is equal to the derivative. You have to find the derivative of that function to get the slope of the line. Okay, so we're going to have to use the chain rule. So first of all, I want to rewrite it in exponential form. So the square root of 4x minus 3 is 4x minus 3 to the 1/2 power. That means that u is equal to 4x minus 3, and du is equal to 4. So just like we've been doing, I want to write the original function in terms of u. So that would be u to the 1/2 power. Then the derivative would be 1/2 u to the negative 1/2 power times du. And so we want to substitute in our values for u and du, which would be 1/2 times 4x minus 3 to the negative 1/2 power times 4. So again, I can divide 2 into 4, it goes 2 times. And so our derivative is going to be 2. And remember, I want to take that to the denominator and put it back in radical form. It'd be 4x minus 3 to the 1/2 in the denominator, or over the square root of 4x minus 3. This represents the slope of the tangent line. That's our derivative. So let me get a little room here. So we need to know the slope, y prime, which is 2 over the square root of 4x minus 3, and we want this at the point 1, 1. So to find the actual slope, remember you guys substitute the x value or x coordinate of that point in for x in the derivative. So the slope to y prime when x is 1, which will be 2 over the square root of 4 times 1 minus 3. And so that's going to be 2. And in the denominator, that'd be 4 minus 3, which is 1. The square root of 1 is 1, so the slope is just 2. So our slope is 2. The point on the line is 1, 1. So using the point slope form, y minus 1 equals 2 times x minus 1. Y minus 1 equals 2x minus 2. And if you add 1 to both sides, y equals 2x minus 1. So there is the equation of the tangent line to the graph of the original function, square root of 4x minus 3 at the point 1,